I'm going to be going through the entire review sheet in this video. So if you do have any additional questions, please let me know, and I will hopefully cover them. Now, the first 12 problems we're going over factoring polynomials. Polynomials is just another way, or a type of, well, quadratics are a type of polynomial function. So all the problems that, or all the equations that we'll be factoring, not equations, these here, these quadratics, are polynomials. We're going to be factoring. Now, the first step in factoring is greatest common factor. We factor out a greatest common factor. Second step is two sets of parentheses with three spaces. Third step is to find the signs. If the third term is negative, or sorry, third term is positive, the signs are the same and match the sign of the middle term. The other option is if the third term is negative, the signs are opposite. Once we finish finding the sign, we need to find the factors of the first and third term. And plug in. And the last step is to check. So those there are all the steps for factoring. So if we look at the first problem, 7b squared minus 63b plus 140, there's a greatest common factor of 7. And when we factor 7 out of each term, we get b squared minus 9b plus 20. And once we finish factoring it out, we can do our two sets of parentheses with three spaces. To find the sign, we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, the third term is positive, so the signs are the same and match the sign of the middle term, which would be minus and minus. Now we need to find the factors of the first and third term. Factors of b squared, there's only one set of factors. It is b and b. Factors of 20, 1 and 20, 2 and 10, 4 and 5. I'm going to pick 4 and 5 first. Then we can check it. b times negative 5 is negative 5b. Negative 4 times b is negative 4b. Negative 4b minus, or negative 5b minus 4b is negative 9b. So these are the correct factors. If you check the middle term and get something other than negative 9b, change change some of the factors and try again. So keep trying until you get the correct factors. Let's look at number 2. Now again, first thing we need to determine if there is a greatest common factor. So we're looking at 9, 36, and 45. Well, it does work out that 9, 36, and 45 are all divisible by 9, so we can factor the 9 out. So that once we factor it out, we get 9 times r squared minus 4r minus 5. Two sets of parentheses with three spaces. Now we're going to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. Here, our third term is negative, so one's positive, one is negative. Now we need to find the factors of the first and third terms. Well, our factors of r squared are r and r. Those are the only factors. The only factors of 5 are 5 and 1. Now at this point here, we can check to see if this works. R times negative 1 is negative r. 5 times r is plus 5r. Negative r plus 5r is a positive 4r. We need it to be negative. So since it's the correct number but wrong sign, we're going to change the signs. Minus, plus, if we check this again, r times 1 is positive r. Negative 5 times r is negative 5r, which gives us a negative 4r. That is the middle term we want. So these here are the factors. This is the factored form for number 2. Number 3, again, the first thing we look for is greatest common factor. Well, between 3h squared, 11h, and 6, there is no greatest common factor. So we can do our 2 sets of parentheses with 3 spaces. Now we look for the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, since the third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Takes us to our next step, factors of the first and third term. 3h squared, well, h squared's only factors are h and h. The only factors of 3 are 3 and 1, so we'll just plug those in. Now, factors of 6 are 1 and 6 or 2 and 3. I'm going to try 2 and 3 first. Now, I can't put the 3 with the 3h because that would give us a greatest common factor of 3. And if there's not a greatest common factor to begin with, there can't be one in either set of parentheses. So the only way we can use 2 and 3 is if the 3 and the 2 are not next to each other. Now at this point here, we can check our terms. 3h times 3 is 9h. 2 times h is plus 2h, which gives us 11h. And positive 11h is the middle term we want. So these here are our factors. Okay, let's look at number 4. Now, number 4 does not have a greatest common factor. So we'll have 2 sets of parentheses with 3 spaces. Find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, third term's positive, signs are the same, match the sign of the middle term, so we'd have minus and minus. Factors of the first and third term, 6x squared and 1. Factors of x squared are x and x. Factors of 6 are 1 and 6 or 2 and 3. I'm just going to pick 2 and 3. Factors of 1 are 1 and 1. So we'll distribute these here. 2x times negative 1, negative 2x. Negative 1 times 3x is negative 3x. Negative 2x minus 3x is negative 5x, which is the middle term we wanted. So these are the factors here. 5. 3n squared plus 5n minus 2. There is no greatest common factor. So we'll have 2 sets of parentheses with 3 spaces. Find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So we have positive and negative, just because the third term is negative. Our next step is to find the factors of the first and third terms. Well, first term, factors of n squared is n and n. Only factors of 3 are 3 and 1. Factors of 2 are 1 and 2. I'm just going to plug it in. And lastly, we can check. 3n times negative 1 is negative 3n. 2 times n is plus 2n, giving us negative n. Well, that's not what we wanted. So I'm going to just switch the 3 and 1. Or no, 3 and 1, 1 and 2. So 1 and 2. And try again. 3n times negative 2 is negative 6n. 1 times n is plus n, giving us negative 5n. That is the correct number, but wrong sign. And And whenever we get the correct number but wrong sign, we change the signs. And if we check it one more time, 3n times 2 is 6n. Negative 1 times n is negative n, giving us positive 5n. That is the middle term we wanted, so we get this here. Number 6, there is no greatest common factor, but the first term is negative. So to make this easier to work with, we're going to factor the negative out. And factoring a negative out just changes the signs from positive to negative or negative to positive. And for us, it made our 3t squared go from negative to positive, which is going to make it easier to factor. Now that we have that factored out, we're going to do our two sets of parentheses with three spaces. Now that we have that, we can find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So since the third term is positive, our signs are the same and match the sign of the middle term, which is minus and minus. Now we're finding the factors of the first and third term. So we're finding the factors of 3t squared. Well, t squared is going to be t and t. Factors of 3 are 3 and 1, so we can just say 3t and t. Now factors of 6 are 1 and 6 or 2 and 3. I'm just going to use 2 and 3. And then check this here. 3t times negative 3 is negative 9t. Negative 2 times t is negative 2t, which gives us negative 11t, which is the middle term we want. And we get this here, because again, we're checking back this middle term, not the original. And that's it. Number 7, again, greatest common factor first. There is not one, but because the first term is negative, we're going to factor it out to make this easier to work with. And since that was the only greatest common factor, we'll do our two sets of parentheses with three spaces and then look at our signs. Since the third term is negative, our signs are opposite. If the third term had been positive, the signs would have been the same and matched the sign of the middle term. Now our factors of 4c squared, well, we will have c and c for c squared. Factors of 4 are 1 and 4 or 2 and 2. We can start off with 2 and 2. Only factors of 5 are 1 and 5. Now at this point we can check. 2c times negative 5, negative 10c. 1 times 2c is plus 2c, negative 8c. Negative 8c. Now if we switched the 1 and 5, 5, 1. For this one here, it's not going to change much. 2c times negative 1 is negative 2c. 5 times 2c is positive 10c this time, which gives us positive 8c. So instead of switching the 1 and 5 again, I'm going to switch the 2 and 2 to 1 and 4. 2 and 2 is out, so one of them will be 4, the other will be 1. And we can check it again. 4c times negative 1 is negative 4c. 5 times c is plus 5c, giving us positive c. Okay, that didn't work. Last possible arrangement. 1 and 5. We can check this here. 4c times negative 5 is negative 20c. 1 times c is plus c, giving us negative 19c. And that is indeed the middle term we want. So that is our solution there. The next one, 4n squared minus 49. This is a difference of perfect squares. Our difference of perfect squares, a squared minus b squared is equal to a minus b times a plus b, or we can say a plus b times a minus b. And in this case, we do have a difference of perfect squares. 49 is 7 squared. 4n squared is 2n, because 2n times 2n is 4n squared. 7 times 7 is 49. So it is our difference of perfect squares. And in our case here, a is 2n, and since it was first, it goes first. 7 is our b. It goes second. So 4n squared minus 49 is 2n plus 7 times 2n minus 7. Or we could say 2n minus 7 times 2n plus 7. We can have it in either order. 9. We do have two terms being subtracted, and one of them does have an x squared. So the question is it a perfect square? Well, I can take the square root of 196, which is 14, so it is a perfect square. I can take the square root of 144, and that's 12. And x squared is a perfect square. So if we're looking at this, we can say it's 14 squared minus 12 squared. So our a in this problem is 14x, so it would go first in both cases. Our b is 12, and we would have plus and minus. Now, there is a greatest common factor in both. The greatest common factor in the first one is 2. We also have a second one in the other. And if we factor it out of the first term, we have 7x plus 6. Factor it out of the second one, we have 7x minus 6. Our 2 times 2 does give us 4. So the completely factored version of this would be this here. 4 times 7x plus 6 times 7x minus 6. I will take it in either this form or this form. Either one. You just have to give me one of them. And if you do have additional questions, please ask about these or email me, let me know. A squared minus 25b squared. If we want to write it in this form, well, a times itself gives us a squared. 5b times 5b gives us 25b squared. So in factored form, it'd be a plus 5b times a minus 5b. We get these here. All right, the last two that we're just factoring are these two here. So with number 11, the first thing we're looking for is a greatest common factor. And there is not one. So we'll do our 2 sets of parentheses with 3 spaces, followed by finding the sign. Since the third term is positive, the signs are the same and match the sign of the middle term. If the third term was negative, the signs would be opposite. Here, the third term is positive, so the signs are indeed the same, and they do match the sign of the middle term. So we have minus and minus. Now we need to find the factors of the first and third term. Factors of a are a and a. Now, factors of 196, there are a few. We have 1 and 196. We have 2 and 98. 3 is not a factor, but 4, I think it's 40. 196 divided by 4, 49. 5 is not divisible, 6 is not divisible. I believe 7 is. Not 4. Add x inverse. 7. Let's try that one more time. 196 divided by 7. 28. 728. 196 divided by 8 doesn't work. 196 divided by 9 doesn't work. 196 does not divide by 10 or 11. 196 divided by 12, decimal. 196 divided by 13 is a decimal. 196 divided by 14 is 14. So, and that's it. I'm going to go on and try 14. 14. And if we do check this here, a times negative 14 is negative 14a. Negative 14 times a is negative 14a, giving us negative 28a. That is the middle term we want, so these are the factors. Incidentally enough, because they are the same factors, we could rewrite it as a minus 14 squared, because a minus 14 times a minus 14 is the same as a minus 14 squared. And that's it. Let's look at the last one that we're factoring. There is no greatest common factor, so we'd have our two sets of parentheses with three spaces. If the third term is positive, the signs are the same and match the sign of the middle term, so we'd have plus and plus. If the third term had been negative, the signs would have been opposite. Now we need to find the factors of the first and third term. Well, factors of x squared are x and x. Factors of 144 are 1 and 144, 2 and 72. 3, 4, 48. 48. 4, 4, 12, 24, 36. 144 divided by 4 is 36. 144 won't divide by 5, but it will divide by 6. 6 and 24. 144 will not go into 7, or 7 will not go into 144. And 144 will definitely not go into 7. Divided by 8 and 18. 9 does not work. Oh, sorry, I was wrong. 9 and 16. 10 does not work because it does not end in 0. 11 doesn't work. And last but not least, 12 and 12. So we have a lot of ones here. I'm just going to start at the bottom of the list, 12 and 12. And if we check this here, x times 12 is 12x. 12 times x is plus 12x, which gives us 24x, which is the middle term we want. So these are the factors. Now, just like with the previous one, we can rewrite it as x plus 12 squared because our two factors are the exact same. And that's it. Now the next one, 13, 14, 15, 16. So for these here, all you got to do is plug them in. 64 squared minus 54, or 64 squared minus 25 squared is 3,471. So the answer to this is 3,471. That's it. 14, 441 squared minus 361 squared. Is 64,160. Then we do the next two. 1,089 squared minus 961 squared. $262,400. That is it. And the last one, 144 squared minus 64 squared. Is 16,640. And that's it. So 13 through 16, you just got to plug it into the calculator and let it do the work for you. Solve each equation by any means. Now, we did have several methods for solving. One was, the first method we went over was factoring, just like we did with problems 1 through 12. We factor the quadratic into two sets of parentheses being multiplied together. Whenever we have two or more things multiplied together to equal 0, one of them must be 0. 2, graphing. We graph it and try to see what values of x will make y be 0. 3 was the square root method. And we get the term being squared by itself, square root both sides, and solve. 4 is completing the square. I will write the steps for it in a little bit. And the last method is the quadratic formula. And we could use any of these methods for these next set to solve. So our x squared plus 3x plus 2, if we wanted to solve this by factoring, first thing we would do is get rid of any greatest common factors. Well, there's not any. So we do our 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and match the sign of the middle term. So we have plus and plus. Now we need to find the factors of the first and third term. Factors of x squared are x and x. Factors of 2, 1 and 2. There's only one for each of these here. Now the next thing we can do is check and make sure we factor this correctly. X times 2 is 2x. 1 times x is plus x. 2x plus x is indeed 3x. Now, since we're solving, we have 2 things multiplied together to equal 0. So one of them must be 0. We set them equal to 0 and solve. So for the first one, we would subtract 1 from both sides, telling us x is equal to negative 1. The next one, we would subtract 2 from both sides, telling us x is negative 2. So if we solve this by factoring, we would say x is equal to negative 1 and x is equal to 2. We can also solve this by graphing. So if we want to solve it by graphing, we plug the function in, x squared plus 3x plus 2. Graph. And again, we're looking for what values of x will make the y value be 0. We can so second graph and look at the table. Negative 2 and negative 1 do have y values of 0, telling us x is equal to negative 2, x is equal to negative 1. Those are our 2 solutions. Now, if we really wanted to, we could use the quadratic formula. In this case, a is 1, b is 3, c is 2. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times a times c all over 2a. At this point, we'll have negative 3 plus or minus. Our 2 times 1 is 2. Now we do need to simplify what's inside the radical. 3 squared minus 4 times 1 times 2 is 1. Now we can simplify that radical because the square root of 1 is 1, and we get this here. Now we can simplify it because x is equal to negative 3 plus 1 over 2, and x is also equal to negative 3 minus 1 over 2. And if we plug this whole thing in the calculator, fraction, negative 3 plus 1 over 2 is negative 1. So x is negative 1. We can do the same with our negative 3 minus 1. Fraction, negative 3 minus 1 all over 2 is negative 2. So we get this here. So again, that's another way we could do this. And I'm going to do this one more. I'm not going to do this with all of them because it's going to take way too long. I might do some of the different methods with some of them. But if we did this with completing the square, is a equal to 1? Yes. Get the constant terms by themselves. So we would subtract 2 from both sides, telling us that x squared plus 3x plus blank is equal to negative 2 plus blank. So step 1 is a equal to 1. If not, make it so. A is a 1. Step 2, get the variables by themselves and leave 2 spaces. We did that because we needed the x squared and 3x by itself. Step 3, find the value of c, which is equal to, or c is equal to b over 2 squared. Find its value and plug in. Well, b in our case is 3. 3 halves squared, because 3 halves will not reduce, is 9/4. So we're going to plug 9/4 in to both sides. Now our x squared plus 3x plus 9/4 will factor. Set of parentheses in x. And we plug in to the parentheses, what goes with it is whatever we had before we squared to find c, and it's positive 3 halves. So we have x plus 3 halves squared. The other side, we have negative 2 plus 9/4, which is 1/4. Now, since we do have a set of parentheses squared equals a number, we can take the square root of both sides. The square root and square will cancel, telling us x plus 3 halves is equal to plus or minus. Take the square root of 1/4. What we would do is take the square root of 1 over square root of 4. Fraction, second square root of 1 over second square root of 4, which is 1/2. And last but not least, we need to get x by itself, so we would subtract 3 halves from both sides. And this tells us that x is equal to negative 3 halves plus or minus 1/2. So it's telling us we have two statements. Negative 3 halves plus 1/2, x is equal to negative 3 halves minus 1/2. Negative 3 halves plus a half is negative 1. Negative 3 halves minus 1/2 is negative 2. So we get this here. Graphing, factoring, quadratic formula, completing the square. For this problem here, all of them gave us the same values, that x is negative 1 and x is negative 2. It did not give us a different value. They are the same. We just need to pick a way to do these. The next one, we're going to solve by the square root method. The reason we know we can do it by the square root method is there is not a middle term. There is not an x. So what we can do is get our squared term by itself. And we do that first by adding 9 to both sides. Minus x squared is equal to 9. At this point here, we can take the square root of both sides. Square root of x squared is x. Anytime we take the square root of both sides, we add the plus or minus, and the square root of 9 is 3. Now at this point here, we would solve, but since x is already by itself, we're finished. That is the answer. Now if we want to graph this, we do need to get it equal to 0. It is already equal to 0. So we can grab the graphing calculator, hit y equals, clear that out, say x squared minus 9 graph. We do see that it crosses the x-axis in 2 places. We can say second table, get a little bit better look at it. There are 2 values of x that make the y value be 0. One of them is negative 3, and the other is 3. So we have 3 and negative 3, which is the same thing we had with square root method. If we wanted to factor this, x squared minus 9 is a difference of perfect squares. So we have x plus 3 times x minus 3. X plus 3 equals 0, x minus 3 equals 0. Now we just need to solve. For our x plus 3, we would subtract 3 from both sides. Minus x is negative 3. Our other one, we would add 3 to both sides. Telling us x is equal to 3. And that's it. We only have to pick one of those methods. We don't have to do them all. You just need to pick one of those methods to find the value of x. That makes the function equal 0. Number 19, no matter which method we do, we will need to get the 2x over with the x squared. That does give us 1/5 x squared minus 2x plus 6 is equal to 0. Since it already is equal to 0, we can graph it. If you're going to graph it, you have to get the equation equal to 0. Graphing, we do y equals alpha. Y equals enter will give us our fraction. So we can say 1/5 x squared minus, make sure, yes, minus 2x. Plus 6. Graph. It does not cross the x-axis. And since it doesn't cross the x-axis, there are no real solutions. So it means our solutions will have I in them. Now at this point here, there's two ways we can solve it. But the first thing I would do, just to make these numbers work out nicer, is we're going to multiply everything by 5. Now the reason we're multiplying everything by 5 is because when we do 5 times 1/5 x squared, 5 times 1/5 is 1, leaving us with x squared. 5 times negative 2 is negative 10x. 5 times 6 is plus 30. And 0 times 5 is 0. Now at this point here, we can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Value of a in this case is 1. B is negative 10, C is 30. So we have negative B, negative 10, plus or minus the square root of B squared, so negative 10 squared, minus 4 times A, which is 1, times C, which is 30, all over 2 times A, 2 times 1. Now at this point here, we do need to simplify a little bit. Now our negative 10 is going to be positive 10. Our 2 times 1 in the denominator is 2. Now we are going to figure out what goes inside the radical, because we have negative 10 squared minus 4 times 1 times 30, which is negative 20. So when we do some simplifying, we are saying that x is equal to 10 plus or minus the square root of negative 20 over 2. Now we can't leave it as the square root of negative 20. We have to do some simplifying. Now to simplify the square root of 20, the negative will come out as I, leaving us with the square root of 20. 30xs will take the square root of 20. It will not take the square root of negative 20, telling us that this is 2 square root of 5. So the negative 20 is 2I square root of 5, because the negative came out as I. Square root of 20 reduced to 2 square root of 5, so we get this here. Now I will take this as your answer, so if you did give me this as your answer on the test, I will take it as the correct answer. Now if we wanted to, we can simplify, because 10 and 2I both have a common factor of 2 with the denominator. Simplifying it to 5 plus or minus I square root of 5. So that is the simplified version of the answer. I will take either. You just need to give me one of them. All right. Well, I said I wasn't going to do this, but I'm going to do it anyways. Now we can do this by completing the square also. It'll work just fine. Is a equal to 1? Well, yes, we made it 1 by multiplying everything by 5. Now we need to get the variables by themselves in the constant terms on the other side and leave 2 spaces. We have now done that. Now we need to find the value of C and plug it in. Well, C is equal to B over 2 squared. Well, our B value in this case is negative 10. Negative 10 divided by 2 is negative 5. And negative 5 squared is 25. So we plug 25 into both spots. Now the reason we do this is to get our set of parentheses squared, our perfect square trinomial. So we'll have x. Now the number that goes inside the parentheses when we factor is the number that we have inside the parentheses before we square it to find our value of C, negative 5. On the other side, negative 30 plus 25 is negative 5. Now, since we have it factored, we can finish by solving. So we'll take the square root of both sides. Square root and square will cancel, telling me that x minus 5 is equal to plus or minus our square root of negative 5. Well, the negative would come out as I. Square root of 5 does not simplify, so we get this here. Last but not least, we would add 5 to both sides, telling us x is equal to 5 plus or minus I square root of 5. We do get to the same answer. Here we didn't need to simplify. It worked out nicely. So we get these two here. All right. 20. Problem number 20. This here, the easiest method is going to be the square root method because we have a set of parentheses squared. All we need to do is get them by themselves first. We can subtract 2 from both sides. Telling us 4 times x minus 1 squared is equal to 8. Since the set of parentheses being squared is not by itself yet, we can divide both sides by 4. Telling us x minus 1 squared is equal to 2. Now, since the set of parentheses, or the term being squared, is by itself, we can take the square root of both sides. The square root and square would cancel, telling us x minus 1 is equal to plus or minus square root of 2. We could plug the square root of 2 into the calculator, and it will tell us that that is as simplified as it gets, so we don't have to do anything else with it. Last thing we need to do is get x by itself, so we can add 1 to both sides, telling us x is equal to 1 plus or minus the square root of 2. We could have tried to graph it, got it set equal to 0, and then plugged it in, but as we see here, this answer is irrational, so we would not have gotten nice numbers by factoring. Number 21 is the same as 20. I could try graphing it, and to graph it, I would subtract 8 from both sides, get this thing equal to 0. X plus 2 squared minus 13 is equal to 0. Let's just clear that whole thing out. 2 times x plus 2 minus 13. 2 times x plus 2 squared minus 13 is this here. It does not cross at nice points, so we're going to have to do the square root method anyways. I'm just going to reset and just add 5 to both sides first, because we need to get the set of parentheses, or which is the term being squared, by itself. And if we add 5 to both sides, we get 13. Next thing we need to do to get this set of parentheses being squared by itself is divide by 2. Those will cancel. And it'll tell us that x plus 2 squared is equal to 13 halves. Next thing we need to do is take square root of both sides, because the square root and square here would cancel, telling us that x plus 2 is equal to, again, anytime we take the square root of both sides, we add the plus or minus. Now to simplify our square root of 13 halves, in the 30xs, we'll take the square root of 13 over the square root of 2. Square root of 13 over square root of 2 is square root of 26 halves. And we get this here. Last but not least, we need to get x by itself, so we would subtract 2 from both sides, telling us x is equal to negative 2 plus or minus the square root of 26 over 2. That is our final answer, and since it is an irrational answer, that is why we were not able to graph it. 22, x squared plus 100. Well, it already equals 0. Might as well try to graph it. Y equals, clear, x squared, not minus, plus 100 is nowhere on the graph. And even if we look at this, the numbers are all way too big. It would have been nice if it had been x squared minus 100, because that would have crossed the x-axis. This one does not. So there are different ways to do this. I would do it by the square root method, because there is no middle term. So the first thing we're going to do is get x squared by itself. I'll subtract 100 from both sides. So it'll tell us x squared is equal to negative 100. We can square root both sides. It's going to tell us x is equal to plus or minus. Anytime we take the square root of both sides, we will add the plus or minus. The negative is going to come out as I, and the square root of 100 is 10. So we get plus or minus 10i. And that's it. Again, I'm going to show you another method we could do this. We could use the quadratic formula on it. And if you're wondering where I got the 0x, well, that is our middle term. Since b, because again, it's coming back to our ax squared plus bx plus c. Since this bx is missing, it just means the value of b in this case is 0, or we can look at it as 0x. A, the number in front of x squared is 1. So if we plug this into the quadratic formula, our negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b, negative 0. Plus or minus the square root of 0 squared minus 4 times a, which is 1 times c, which is 100 all over 2 times a. Negative 0, well, that's just 0. 2 times 1 is 2. Now I'm going to plug everything inside the radical first, so 0 squared minus 4 times 1 times 100. Yep, is negative 400. Now we can do some simplifying still. The 0 plus or minus, well, we can just say plus or minus because 0 is not adding anything to it. We still have the 2. If I simplify the square root of negative 400, we will have I leaving us with the square root of 400. Calculator. Square root 400 is 20. So we have 20i over 2. 20 divided by 2 is 10i. We get the same thing. And again, quadratic formula works. It just takes a little bit longer. Completing the square would work. It is more complicated than it needs to be because then we're looking at b as 0. Don't mess with it. 23. We're going to solve this by factoring. Because we have two things multiplied together that equal 0. This is just zero product property. Two things multiplied together to equal 0. One of them must be 0. If we have two things being multiplied together, there will be at least one of these on the test. Nudge, nudge, wink, wink. It will be there. If it starts off like this and it's asking you to solve it by factoring, set both of them equal to 0. So here the 2x minus 7, we set equal to 0. The 5x plus 13, we set equal to 0. Now we just need to solve for the value of x. So we have 2x is equal to 7. Divide both sides by 2, telling us x is 7/2. We're done. The other one, subtract 13 from both sides, telling us 5x is equal to negative 13. Divide both sides by 5. X is equal to negative 13/5. That's it. There's no other reason to do it by any other method than this here. Because any other method would require us multiplying these out. There's no reason to do that. This is it. Questions 24 and 25. There will be two questions on the test that specifically ask you to solve by using a specific method. You can solve it by another method. You will just lose the one or just a few points for doing it by the other method, by the non-correct method. But I would rather you get the correct answers if you get stuck on not being able to do it by one method or another. So here, it's wanting us to do these by completing the square. Completing the square. Step 1. Is A equal to 1? If not, make it so. Step 2, get the variables by themselves. And leave 2 spaces. There's going to be 1 space on either side of the equal sign. 3, find the value of C, which is equal to B over 2 squared, and plug it in. Last but not least, factor and solve. These are the 4 steps to completing the square. So if we look back at 24 and 25, 24, first step, is A equal to 1? Well, no, A is equal to 2. So if not, make it so. So we're going to divide everything by A. So in this case, we're dividing everything by 2. 2x squared divided by 2 is x squared, minus 12x divided by 2 is 6x. Negative 24 divided by 2 is negative 12. And 0 divided by 2 is 0. So A is now 1. We can move on to step 2. Step 2, get the variables by themselves. So we need to move our negative 12 by adding 12 to both sides. And it'll tell us that x squared minus 6x plus blank is equal to 12 plus blank. We got the variables by themselves, and we needed to leave 2 spaces, 1 on either side of the parentheses, so we get this here. Next thing we need to do, step 3, is find the value of C and plug it in. Well, our C is equal to B over 2 squared. AX squared plus BX plus C. Our value of B in this case is negative 6. So we'd have negative 6 over 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. And what that's telling us, x squared minus 6x plus 9 is a perfect square trinomial. We can rewrite it as a set of parentheses squared. We will have x. And the number that goes inside the parentheses with it is the number we have inside our parentheses before we square it in solving for C, which is minus 3. So x minus 3 squared is the factored form of x squared minus 6x plus 9. Now we have x plus 9 on the other side, which gives us 21. Because we couldn't just add the 9 to one side, we have to add it to both. Now we can solve by taking the square root of both sides. And when we take the square root of both sides, our square root and square would cancel, telling us x minus 3 is equal to plus or minus. Whenever we take the square root of both sides, we have to add the plus or minus. Now we can plug the square root of 21 into the calculator and see if it simplifies. It does not. So we can leave it as the square root of 21. And our last step in solving is to get x by itself. So we'll add 3 to both sides. Minus x is equal to 3 plus or minus the square root of 21. And that is it. I'm not going to go over doing this by the quadratic formula because it's specifically asking just for the square root method. We will do a few more with the quadratic formula here in a little bit. (25). Now we can go through the process of getting this equal to 0, but luckily with the square root method we don't technically need it equal to 0, but we can if we want, because I can add 50 to both sides. And if we add 50 to both sides, we get 5x squared plus 30x plus 50 is equal to 0. First step, is A equal to 1? If not, make it so. Since A is not 1, to make it 1, we have to divide everything by 5. 5x squared divided by 5 is x squared. 30x divided by 5 is 6x. 50 divided by 5 is 10. Step number 2. Get the variables by itself and the constant term on the other side. Well, if and leave 2 spaces. So as we see here, we could have left the negative 50 over there. It was already by itself, but it isn't wrong to move it over, then move it back. Let's go with this color. Now we need to find the value of C to make this a perfect square trinomial. And once we find the value of C, we plug it back in. Well, C is equal to B over 2 squared. Our value of B in this case is positive 6. 6 divided by 2 is 3. 3 squared is 9. Now, it's not always going to be 9. It just worked out this way that they were both 9. But that works. Now that we plugged it in, we can move to the last step, which is factoring it. The number that goes inside the parentheses with x is the number in sign of whatever we had before we squared it. So in this case, it's positive 3. Now we can solve. First step in solving is to take square root of both sides. Well, here the square root and square will cancel. Minus x plus 3 is equal to plus or minus square root of negative 1. Well, the square root of negative 1 by definition is I. And last but not least, to get x by itself, we would subtract 3 from both sides, telling us x is equal to negative 3 plus or minus I. And that's it. That's all we have to do for this one here. Question 8 and 29. Find the value of the discriminant, the type of solutions, and find the value of the solutions. We're not going to worry about finding the value of the solutions. We're just going to find the discriminant and describe the type of solutions. How to do this? Well, discriminant. The discriminant is our b squared minus 4ac. Now, if b squared minus 4ac is less than 0, we have two complex solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is greater than 0, we have two real solutions. So we have one of these three setups, and it's going to be determined based off the value of our discriminant. One of the first things we need to do to find the value of the discriminant is we need to make sure this thing is equal to 0. Doesn't matter how we do it. We can subtract 4x squared from both sides, telling us 0 is equal to negative 4x squared plus 5x minus 10. Yep. So our value of A is negative 4. The value of B is 5. The value of C is negative 10. So we want to find the value of the discriminant. Negative B minus 4ac. So for us here, it'd be 5 squared minus 4 times negative 4 times negative 10. At this point here, we can plug it into a calculator. 5 squared minus 4 times negative 4 times negative 10 is negative 135. Since this is less than 0, we have two complex solutions. That's all I want. I'm not going to ask you to actually solve these here when you're talking about the discriminant. We just need to get it equal to 0 and go from there. I knew I skipped something. We'll come back to that. 29, we're doing the same thing, but we do need to get this thing equal to 0. So we're going to subtract x from both sides. And if we subtract x from both sides, we get negative 2x squared minus x minus 6 is 0. So for us here, A is negative 2, B is negative 1, and C is negative 6. Now, not wrote the quadratic formula. We don't need that. We just need the discriminant, our b squared minus 4ac. Our value of b is negative 1. Our value of a is negative 2, and our value of c is negative 6. 1 squared minus 4 times negative 2, negative 6 is negative 47. Since that's less than 0, we have two complex solutions. And that's it. Well, let's go on and do the third type for a third one we had for this. And again, we need this thing equal to 0. So I'm going to subtract 24x from both sides. Now I am going to rewrite it in standard form. So our negative 3x squared minus 24x minus 48. So our value of a in this case is negative 3. Value of b is negative 24. Value of c is negative 48. So our b squared minus 4ac. b is negative 24. So negative 24 squared minus 4 times negative 3 times negative 48. Again, we can plug this in. Parentheses, negative 24 squared minus 4 times negative 3 times negative 48 is 0. And since it is equal to 0, we have one real solution. Now, if it had been greater than 0, we would have had two real solutions. So if the value is greater than 0, we have two real solutions. If it's equal to 0, we have one real solution. If it's less than 0, we have two complex. Quadratic formula. Now at this point here, I've written the quadratic formula several times. I'm going to go on and write it again. Square root, or x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And before you can use the quadratic formula, you do need to get this thing equal to 0. And it is also nice to have the value of a be positive. And none of the numbers fractional. So, first thing we can do is add 5 to both sides, telling us that negative 4x squared plus 3x plus 5 is equal to 0. Now to make this thing be positive, we're going to divide everything by negative 1 so we don't have to deal with fixing the signs later. Now what that tells us is that we have 4x squared minus 3x minus 5 is equal to 0. It also means the value of a is 4, value of b is negative 3, value of c is negative 5. And we can plug this in to our formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So our negative b would be negative 3 plus or minus the square root of. So our b squared would be negative 3 squared minus 4. A is 4. C is negative 5 all over 2a, which is 2 times 4. Now our negative 3 would be 3 plus or minus. Denominator 2 times 4 is 8. The last thing we need to do is plug all this into the calculator. Negative 3 squared minus 4 times negative 5 is 89. Now if the radical will reduce, we need to reduce it. Square root of 89 doesn't reduce. So that right there is our final answer, and that's it, all that we have to do for this here. Let's look at the next one. Negative 7x plus 6 is equal to negative 4 squared. Again, we need to get this equal to 0. So we're going to add 4x squared to both sides. And if we add 4x squared to both sides, we get 4x squared minus 7x plus 6 is equal to 0. Since the first term is positive, we don't have to do anything else to it. So we get this here telling us A is 4, B is negative 7, and C is 6. And again, we're referencing back to our ax squared plus bx plus c is equal to 0. A is the number in front of x squared, B is the number in front of x, and C is the number without a variable. So we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to plug in our values. So our negative b would be negative 7 plus or minus b squared, so negative 7 squared, minus 4 times a, 4 times 4 times c, which is 6, all over 2 times a, 2 times 4. Now there are a few things we can simplify. First, our negative 7 would just be 7. The denominator 2 times 4 is 8, square root. Simplify what's inside the square root. Parentheses, negative 7 squared minus 4 times 6 is negative 47. Now we do need to simplify this sum because we cannot leave this as the square root of negative 47. The negative will come out as I, which does leave us with the square root of 47. I will plug it in the 30xs, the yellow calculator, and it'll tell me that it's just the square root of 47. So this here is our final answer. And that's it. If there was a like term to simplify in all three spots, you can simplify it if you want. I will not count off if you do not. But that right there is our final answer. Luckily, we've done 28 through 30. 31 through 33, create a perfect square trinomial by finding the value of c and factor it. So the first thing we need to do for all these here is find the value of c. Well, c is our b over 2 squared. So for 31, first thing we need to do is find the value of c, b over 2 squared. Well, the value of b in this case is negative 24. Negative 24 divided by 2 is negative 12. Negative 12 squared is 144. So our value of c is 144. If we plug it back in, we would have x squared minus 24x plus 144. And to factor it, set a parentheses in x, and the number that goes inside the parentheses is the same number that we got before we squared it finding c, negative 12, and that's our answer here. 32, again, finding the value of c. c is equal to b over 2 squared. And in our case, the value of b is 29, so we have 29 over 2 squared. Now, since 29 does not divide by 2 nicely, we will leave it alone. I want you all to leave it as a fraction if it doesn't reduce. And 29 over 2 squared is 841 over 4. So it tells us our quadratic is x squared plus 29x plus 841 over 4. And if we factor it, we'll have a set of parentheses in x, and the number that goes inside of it is the number we had inside the parentheses before we squared it with its sign. So in this case, it'd be x plus 29 halves squared. $33, we're going to do the same thing. We'll get this color here. C is equal to b over 2 squared. And in our case, the value of b is 49. So we'd have 49 over 2 squared. Now with the last one, if you're wondering if this will reduce, we can plug it in fractional form, and voila, it doesn't. So we can go on and square it. 49 over 2 squared is 2,401 over 4. So our perfect square trinomial would be x squared plus 49x plus 2401 over 4. Factoring x, and again, the number that goes inside the parentheses is what we had inside our parentheses before we squared it to find c, and its sign telling us that it factors to x plus 49 halves squared. Please, on these here, put them in fractional form, not in decimal form. And that's it. Next part, powers of I. If we want to find the powers of I to any power of n, all we need to do is take the power and divide it by 4. If the decimal comes out to be 0.25, it reduces to I. If the decimal reduces to 0.50, it is negative 1. If the decimal is 0.75, it's negative I. And if the decimal is 0.00 or there is no decimal, it reduces to 1. It will reduce to one of these 4. So when we look at this here, I to the 27th, what we need to do is take 27 and divide it by 4. Calculator. 27 divided by 4 is 6.75. I do not care about the 6. I'm only caring about the 0.75. 0.75 tells me this reduces to negative I. The next one, 287. We're going to divide it by 4. 287 divided by 4 is 71.75. Not caring about this 71, the 0.75, just like the last one, will reduce to negative I. I to the 41st, we can divide it by 4. 41 divided by 4 is 10.25. And again, we're not caring about the 10. I focus on the 0.25. 0.25 reduces to I, telling me that this is I. We get this here. The next one, 2,874. Just like the last one, we divide it by 4. 2,874 divided by 4 is 718.5. Not caring about the 718, the 0.5. If we look at our chart, 0.5 is negative 1, so that reduces to negative 1. 6,971 divided by 4 . 1,742.75. Only thing I care about is 0.75. 0.75 tells me this reduces to negative I. That's all we have to do is divide it by 4 and look at the decimal. And the decimal will tell us which power of I we have. Evaluate each expression for any of these here. With these here, I'm going to do one of them. Well, no. We could do these by hand or we can do these in the calculator. Because if we do these by hand, for addition, we would just drop the parentheses, 6 minus 7i plus 4 minus 3i. Add our real terms, 6 and 4. 6 plus 4 is 10. Negative 7i minus 3i. Negative 7 minus 3 would be negative 10i. We get this here. If we wanted to do this in the calculator, we would do it in the graphing calculator, and we would type it in exactly as we see it. 6 minus 7i. To get I, we're doing second decimal. Second decimal will give us I plus 4 minus 3. Second decimal will give us I. Enter 10 minus 10i. We could do the same thing with B, and I would plug it in exactly as I see it. Parentheses 7i minus 27, close parentheses, plus parentheses 3i minus 2, parentheses, enter, negative 20i, 29 plus 10i. And that's it. If we're doing subtraction, if we did it by hand, we would distribute the negative. The first one would be the same, but we have to distribute the negative through the second. Our negative times negative 3i would be plus 3i. Our negative times positive 2 is minus 2. Our 6 minus 2 is 4. Negative 4i plus 3i is negative I. giving us 4 minus I. Again, we can do this in a graphing calculator and type it in exactly as we see it. If we type it into the calculator, we get 4 minus I, which is exactly what we got before. We can look at letter D, and again, type it into the calculator. Parentheses 74 minus 6 I, close parentheses, minus 27 minus 3 I. Enter is 47 minus 3I. And that's it. That's all we have to do with these here. Really, with any of these, we could just plug them in and go from there. Even the next one is as funky and as complicated as that looks. All we got to do is plug it in. So, if we type this one into the calculator, type it in exactly as you see it, 189. Second I minus 361 second I squared, close parentheses, plus parentheses 71 second I squared minus 38 I to the 4th power. Make sure when you type anything after the 4th power, we do go over 1. So when this is simplified, we get 252 plus 189I. And that's it. The calculator can do it for us. The same thing's true with multiplication, because I could do this by hand and we could distribute 7 times 16. 7 times 16 is 112, or 112. Minus 7 times negative 2I is negative 14I. Negative 4I times 16 is negative 64I. Negative 4I times negative 2I is plus 8I squared. 112. Our negative 14 minus 64I is negative 78I. Plus 8. Our I squared is negative 1. Our 8 times negative 1 would be negative 8. Minus 78I. Negative 8 plus 112, or 112 minus 8 is 104, minus 78I. And that's our answer. Now, if we want to type it into the calculator, I would type it in exactly as it shows, exactly as it's written. Parentheses 7 minus 4, second I, close parentheses, open parentheses, 16 minus 2. I is 104 minus 78I. Exactly what we had. So on the next one, we can type it in. 8 minus 2. I, close parentheses, opens parentheses, 6 plus 3I. Enter is 54 plus 12I. And that's it. H. Even though it has 3 parentheses, we can still do the same thing. 2 plus 3I times 7 minus 4I. Close parentheses, open parentheses, 6 minus 2I. Type the whole thing in, we get 182 plus 26I. It still works. And that's our answer. We can do the next one in the calculator. 8 plus 4I times 8 minus 4I. This is a, almost typed it in wrong, 6. 8 plus 4I times 6 minus 4I is 64 minus 8I. we get our answer here. J, again, type it into the calculator. 3 minus 2i times 3 plus 3 minus 2i times 2 plus 3. I almost had that flipped, almost typed the wrong thing in. When we type it in, we get 12 plus 5i. That's it. Last one with multiplication. Again, just type it in. 8 plus, parentheses, 8 plus 4. I squared, close parentheses, open parentheses, 16 minus 3, I to the 5th. Gets us 64 minus 12i. L and M, I'm not going to go through the process of solving these by hand. To type them into the calculator, we rewrite it. We're going to type it in as division. 8 minus 4i in parentheses divided by 3 minus i. You do need the parentheses. 8 minus 4i divided by 3 minus I. Close parentheses. Enter. You get this here. Do not leave it as a decimal. Math, enter, enter. We'll get it as a fraction. 14/5 minus 2/5 I. That there's our final answer. M, again, the numerator in parentheses divided by the denominator, 3 minus 4i, enter. You get this here to turn it back into a fraction. Math, enter, enter. 12 25ths plus 16 25ths. I, that is the final answer for that there. N, again, same thing. We can plug it in the calculator. 8 plus 3 I divided by 6 I. Always make sure to put it in parentheses. We get this here to turn it back into fractional form. Math, enter, enter. 1/2 minus 4/3 I. That is our final answer for that one there. Next one. 8 plus 4 I divided by 16 I is this here. Math, enter, enter. 1/4 minus 1/2 I. That is your final answer. Last one with using these operations. 3 minus 7 I divided by 6 minus 9 I is this here. These are ugly decimals, but if we go math, enter, enter, it does reduce it to fractional form. The denominators are different, and that is fine. We have 9/13 for the first fraction, minus 5/39 I. And that is our final answer for that one there. Now that does bring us to the last four. Apparently I don't have it included. I need to. It says find the complex conjugate and their product. Q, 4 minus 3i. Its complex conjugate is 4 plus 3i. Because if a plus bi is given, its complex conjugate is a minus bi. We change the sign in front of I. Now to find their product, we just multiply these two together. 4 plus 3i times 4 minus 3i. Now we can do this in the calculator. 4 plus 3i times 4 minus 3i, which gives us 25. So the answer for this first one here is 4 plus 3i and 25. R is given to us as 18 plus 14i. its complex conjugate would be 18 minus 14i. And to find their product, we're multiplying them together. So 18 plus 14i times 18 minus, not 14i, 4i. So we're doing 18 plus 4i times, oh, it is. I, for some reason, just didn't type the 14. 18 plus 14i times 18 minus 14i is 520. So that's the answer for that one there. S, 8i. Well, its complex conjugate is negative 8i, because we're just changing the sign in front of I. So we can say 8i times negative 8i is 64. So the answer for this is negative 8i for the complex conjugate, and its product is 64. The last one, negative 19i, its complex conjugate is 19i. And if we multiply them together, negative 19i times 19i gets us 361. And that's it for the complex conjugates and their product. And lo and behold, that is the entire review sheet. So if you do have any additional questions, please ask me. Please make sure to write down all the information that you need on the review sheet, the quadratic formula, the steps for completing the square, the steps for factoring, the steps for reducing the powers of I, information on the complex conjugates, what it is, finding their product, the discriminant, and how to relate the different types. The fact that b squared minus 4ac, if it's greater than 0, it's two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is less than 0, we have two complex solutions. How to find that, and how to type in the division for simplifying our i's dividing to complex numbers. I would make sure I have notes on all that so that you're ready for part 1 and part 2 of the test this week. And that is it.